Welcome, everyone. My name is Lauren Hedges. I am here tonight on behalf of Hackforge. Thank you so much for joining us. We're just after 6 o'clock. I'm going to give people a couple of minutes to finish joining, to get all of their technical pieces set up. I know sometimes Zoom can be a bit of a pain getting your audio and all of that working, so no rush on that. Throughout tonight's event, I apologize for the dog. Throughout tonight's event, if you have any questions, please feel free to put them in the chat. We will address them at the end. You'll also have the opportunity to ask your questions out loud to Brent if you feel like turning on your microphone. But again, that'll be when we get to the end of his presentation. So we are recording tonight, just a reminder. We'll be posting this video within the next couple of days on the Hackforge social medias, and Brave will have a copy of it as well. So with that, we will get things started. A couple more people, always more folks adding, so let those new folks in as they join. So once again, welcome everyone to tonight's Hackforge presentation. This is the first meeting organized by Automate Canada. So I'm going to pass it over to Nicole right now to speak a little bit about Automate Canada. Over to you, Nicole.
Thank you. So like Lauren said, my name is Nicole Volanich, and I am a representative from Automate Canada, as well as the Canadian Association of Mold Makers. I thank you everyone for attending our first collaborative event, and thank you, Brent, for being our first speaker. Automate Canada represents the Canadian industrial automation industry, service providers and suppliers. We're a newer association that began as a subcommittee of CAM, and we just incorporated last year. I look forward to future events with Hackforge, and I hope to see everyone again. And that's it. Back to you, Lauren. Thank you.
Excellent. Thank you, Nicole. Really happy to have this collaboration going between Automate Canada and Hackforge. I think it makes a lot of sense, and I'm glad it's something that we were able to set up. So now then, I'm just going to introduce our speaker for this evening. Brent McPhail is the CEO of Brave Control Solutions Incorporated, a premier control systems integration company that thrives on solving the toughest manufacturing challenges for Fortune 500 manufacturers across North America. Over a 20-year career in manufacturing and automation, Brent's commitment to delivering success for his customers has driven him to seek out and develop the most innovative solutions by combining technologies and best practices from across many competing industries. His passion for driving innovative solutions is rivaled only by his passion for driving Formula Ford race cars. Cool, nice. So thank you, Brent, for being here with us tonight. Really happy to have you, and I will now pass the reins over to you. Take her away.
Okay, perfect. Thank you. So thanks for everybody who has joined. I'm not sure what the expectation is for this presentation, but I've put together some thoughts of some different presentations that I've done over the last couple of years around the subject of snowflake manufacturing. And so what I'll do is an introduction of my company, a little bit about what we do, and then I'll take us through the story of how we kind of realized the problem or the challenge of snowflake manufacturing and where it needed to be defined. We were solving problems for it without even really kind of understanding it. And then I'll talk about maybe the greater manufacturing industry and sort of some of what I see happening and where things could potentially go. So I've got some videos and things that I'll share. And so hopefully for the folks that are here, it'll be interesting. And by all means, I'm open to any kind of questions or whatnot. So, all right, so I will get started. So if you don't mind, I'll just keep my screen running like this. I think it's a little easier for me than pushing it through presentation mode. So about Brave Control Solutions. So we are a system integrator. I founded the company in 2008. We tend to take on tight timelines and tough challenges. And so we have this reputation, I guess, for of that, which is a suiting name for Brave. But Brave is actually just comprised of my two kids, Bryson and Avery. Bryson was born in March of 2008, and he made up the BR, so that's how Brave was named. Historically, we were primarily an automotive company, and as a system integrator, applying the brains, the PLCs, the robotics, and the control panels In 2018, a client approached us to build a 3D volumetric welding machine. We didn't know what that was, but we make welding machines for cars all the time, so we jumped all over it. One of the folks on here, Steve Del Duca from Romat, is one of our partners that worked with us on this original project in 2018 and on a number since then. We have pivoted our, not just our business of what we deliver to delivering construction for automation, but also to delivering full turnkey systems. And so working with folks like Steve to actually build the entirety of the machines. And then in the prefab and offsite construction industry is kind of where we play. So what does Brave do? We build machines in factories to help construction solve its sustainability, productivity, and customization challenges. How we do it is with a product that I'll share and show you guys some demos of we call it CAD to Fab. And CAD to Fab is the underlying technology that solves the Snowflake manufacturing challenge. So we use that to empower solutions. But because construction is and automation construction is so new, we're really just observing challenges and applying different types of technological solutions to them. So what is our goal? I've always been a strong believer that automation works for people. So build systems to empower humans. We call it automating responsibly. What we're seeing more and more in this world is the shortages of skilled trades and just workers in general. And, you know, in the past, I think robotics and automation had this reputation of taking away good jobs. Now we're just trying to basically keep up with the production demands with the workforce that we have. And so it's very important to always remember, have a robot do a job a robot does the best, have a person do a job a person does the best, and you have a really good system. And so what is the challenge here? Well, my question always is, why isn't everything automated, right? We know what these things will solve, but everything's not automated yet. So our legacy customer base includes, you know, prestigious companies that we love to work for, like Ford and GM and Goodyear and Tesla and Chrysler and some others in here. And after we made our pivot, the names have changed considerably. So while we still do a lot of automotive work, companies like Ellis Don, you know, construction companies, HIT Contracting, Burns and McDonald Engineering in the States, Boxable. If you go on LinkedIn right now, about every other ad is a Boxable, Casita. You know, DPR Construction, large GCs, NRB, modular company here, Z Modular, and then Single Bay. So these are people that we've, and there's a number more, but these are people that we're currently doing projects with in the automation for construction range. So the question that I get asked all the time is, you know, I had a very profitable, successful automotive automation business. Why would I disrupt my own business? And I think when you call your company Brave, that tends to be in your DNA, and you do that. But what we realized once we got into construction was it's a $3 trillion industry in North America, compared with about 200 billion for automotive. There's almost no adoption of automation for construction. There is a global housing crisis. Anybody who's lived in Canada for the last and in Windsor region for the last 2 years knows exactly what I'm talking about. We've got incredible shortages. It's driving the price up. However, we also have issues with hotels and hospitality and a lot of other structures. So our demand is increasing. At the same time, we've got a global labor shortage. So, you know, some of the things that we're just now starting to uncover with all of this COVID nonsense and the decisions that were made during COVID to, you know, employ people not to work or pay them not to work, and then another section of the society to basically create a whole bunch of hoops for them to jump through. We've had an unprecedented exiting of the workforce of baby boomers. And so we were already in a situation where we were short of labor, but we were hoping that the baby boomers were going to stay in that workforce longer to sort of make up some of that gap. Well, because of frustrations in their jobs changing and whatnot through this COVID, we've lost, I mean, in the United States, I think it's like 3.2 million additional workers that were baby boomers that were going to stay on. So this global labor shortage is becoming a bigger and bigger problem. The other really big problem for anybody with any kind of social responsibility is this 25 to 30% material waste. And I say it like this, just to think about it, put an exclamation point on it. You know, we have a shortage of hospitals, right? Windsor's going to build a new hospital. And at that rate of waste, 25 to 30%, for every 4 hospitals that we build, we put 1 in the garbage. So when you think about a $1 billion hospital that's being built with a 25 to 30% material waste, and that 1 hospital in 4 is going in the garbage, you know, all of the resources it takes to build, and the time, the energy, and the shortage. And what would that mean if we could drop that number by 5% or 10% or get it down to almost zero? Look at, you know, to the levels of an automotive manufacturer. So this global housing crisis, I don't know the value of going into this, but there's so many facts and figures about how bad this really is. It's not just a shortage of houses, it's a shortage of affordable houses. And there is no current known way to build those houses with our existing means and our existing workforce. Little pun here, we are screwed, literally and figuratively. And so construction is the only industry that has actually decreased in productivity over the last 75 years. You see the graph right here. So all other industries have gotten more effective and more efficient over time. And construction has shown since the 1950s a decrease in productivity. When I look at construction, we always make this joke. It's like, I say it with this company like DPR, multi-billion-dollar GC founded by, a person, and the president owners of that company today, if their great-great-grandfather had come back and said, wow, I'm so impressed. Like, you guys took our little company and turned it into this billion-dollar company. I'm so amazed. So tell me what's changed since when I was running this company. And they would say, well, look at this. This is a nail gun and this is a skill saw. And that's about it. And so that person who was 100 years ago in that business could basically go back to work and start working in that company just as they did 100 years ago. And that's you could not do that in the automotive industry. You couldn't do that in just about any other industry. So what is our current situation? Well, here's automotive that's really only been making cars for just over 100 years. And when you look at the level of sophistication and you look at the level of technology that exists in an automotive plant, you see a line that looks like this. When you look at a construction factory, you still see the same way guys are building a house in that factory, although they're using a crane where they would have had to use some type of an outdoor lifting mechanism to do this, but they're basically building things the same way. So we've got 100 years of time that our automotive has gone to this, and construction has been around for thousands of years, and they're still building things the same way that they used to. So the question I always ask is, why is there this lack of adoption? So what do we know about automation? On the surface, it solves labor shortages. It does dirty jobs. It does unsafe jobs. It's more productive. There's a whole list of reasons that automation is so strong. Couple that with the fact that computer-controlled automation has been around since the late 1960s. So this is actually Unimate, which was the first robot installed at General Motors assembly line in Irving Township, New Jersey in 1961. And the adoption of automation for construction, why has it been so slow? So we know what automation can do to increase our efficiency and solve some of these challenges that we're facing. We know that the technology exists, yet when you look at construction, we're talking about nail guns and skill sets. And on top of that, there have been some attempts. There's a company called Katera, maybe you have or haven't heard of, but they're $1 billion tech startup. And they just finally went bankrupt probably just under a year ago. And so they went through $1 billion trying to solve this automation, this technology challenge for construction. And they had, $1 billion is not unlimited, but that's tremendous resources. And they weren't able to be successful. So I love this quote. You guys have probably heard it. A customer can have a car painted any color as long as it's black. And so what I'm trying to show here is, while the automotive industry is incredibly sophisticated and we're using robots in our, one of these F-150s is coming off the line every 54 minutes or 54 seconds. When you look at how cars were made in 1913, across the river here in Dearborn, Ford's first ever moving assembly line, as to how they're made today in Dearborn, it's the same way. We are still building cars effectively the same way that we've built them for 109 years ago. So we are adding robots, we're adding technology, but at the end of the day, the innovativeness of the assembly line process hasn't evolved after 109 years. And so then I like to ask this question, right? It's this innovation misconception. So here's the Tesla line. Is Tesla innovative? And I don't think anybody in this room would say that they're not innovative. Elon Musk is not this super innovative guy. I mean, he's the first new car company to go public in over 50 years. But when you look at how he's making his cars, he is making his cars the same way that Ford makes their cars, the same way that they made them in 1913. Maybe they have, these AGVs and there's some other additional sophistication, but at the end of the day, we're still making cars the same way. And I would say that Elon Musk understands the Snowflake problem even more. And as I get into the Snowflake problem, this will make sense, but I'll just drop a little kind of tidbit right now. What is the difference between the first Model S that he's made and the current Model S that you would buy today? From the surface, they look the same. Maybe there's some paint colors that are different. Maybe there's some, there's definitely software differences and some sensors, but he hasn't gone through what the automotive guys do, which is made a new generation of his car. He's stretching that out. So when those Teslas first came out, they still look the same. He wants to make something new. He builds a new plant and he builds a new product, such as the Model X or the Model S. The other thing I'll say about innovation, I'll share this quick video. This is just something I threw in just recently because of the news that had just been put around. So when you talk about his innovation, this is this large die-cast machine that they have in their Fremont facility. It's the largest die-cast machine in the world. And they're making, it looks like a battery cradle or some gigantic die-cast components out of this machine. I think this is, there was another video where they're doing like a body side. Innovative, yes, but he's still dealing in a world where he's not making snowflakes, he's making products. So, okay. So now let me go and talk about the F-150, which is one of my favorite trucks. And it's also a story that I love to tell. And this is kind of when we began to understand the snowflake problem. So what would you define complexity as? Well, there is 1 billion different configurations of this F-150. When you factor in leather with colors, powertrains, wheel sizes, rims, interior sizes, capabilities, there's over 1 billion configurations. That I would say ranks up there very high when it comes to complexity. But what I would say about the F-150 is there's one thing about that complexity that is always true, and that is it. And all 1 billion of its configurations are known before you build a factory to build 1 million of them a year or one every 54 seconds. And why that is so crucial is that it's a product, and even though it's a highly flexible product, it is known before the factory is built. And there's an importance to that order. So when I talk about snowflake manufacturing, and now I'm finally through the sort of about brave marketing stuff, and we can talk a little more about this thing that we've uncovered, what snowflake manufacturing is and how I feel it certainly impacts construction and how I think it's going to impact just general manufacturing overall going forward. So snowflake manufacturing, there's a hotel, there's a multi-unit residential, there's a hospital or a long-term care, and there's a Starbucks. And so if you were to take a look at these things, let's say you were an alien, and you broke them down into their subcomponents, you would find that they're probably very similar, right? They have plumbing in the walls and electrical in the walls, and they're made of like, you know, drywall and wood, and, you know, there's a structure and the rooms are square and they have doorways and windows. And so there's a lot of consistency about here. But why I say it's market driven is somehow the Ford Motor Company back in 1913 was able to convince the market, here are the options of the truck you can have. That's all you get. Nobody comes to Ford, you know, because their dad's really rich and their kid's at MIT and designs a new pickup truck and says, you know what, why don't we see if Ford's not running that line on the weekend and maybe they can run 10 trucks for us. My dad's rich, he'll pay for it, pay $1 million a truck. Nobody would ask that question because it's completely preposterous. But when it comes to building an automated factory for construction, that's what happens every single time. So our first client came to us and said, could you build a 3D volumetric welding machine? Our first hotel has 150 different like rooms, right? It's different sizes. And so we looked at that like 150. Yeah, that's in today's technology and our processes and our computers, like that's very easy to do. It doesn't take up any data. We can absolutely do that. So we set off making this design to have our robots be flexible and to be able to build these 150 different units. And then they came to us midway through our design and said, guys, we've got some great news for you. And the great news is we've sold another one of these hotels. And we were like, oh my God, this is awesome. Like, you know, we're going to build you guys more machines and this is going to be fantastic. And then they said the thing that changed all of the lives of the engineers in my company forever. And that is, so as soon as the architects get done designing the next hotel, we'll get those prints over to you guys to make sure to work in your machine. And that's when we all stopped and we said, it doesn't work that way. You can't tell us tomorrow that you want to build, you know, maybe it has different joist spacing or a different material thickness or a different length or different height or different dimension. You can't tell us that after we've built the factory. It doesn't work that way. You've got to tell us everything ahead of time. And their response to us was, it never, ever will work ahead of time. You've got to figure this out because we need a machine that can continue to evolve and to grow when we have our changes in our products. And so why I call it automation for construction is a paradigm shift. Snowflake manufacturing means that the product can continue to change after you've established the machine parameters. And so your machine has to have that flexibility built into it to be able to handle that. But why I say it's a paradigm shift is that type of thinking is just the beginning. This goes through every aspect of a market-driven product manufacturing. So the answer to the question is of why have we not seen any adoption of automation in construction over the last 60 years is because it's really, really hard to do. So human beings are the best robots on the planet. When somebody gives them a new set of blueprints, if they need to, they'll make their own tool to be able to make the thing that they're making. But when you live in the world of a robot, all you live in are constraints. And so you have to be able to identify what those constraints are. Robots they're bad at varying things. And so the paradigm shift is understanding that, here would be an example. You've got a piece of wood, and that wood has the ability to be flexed, to be straight. And if anybody's ever worked with, wood construction, what does the guy do? He grabs it, he convinces it into position, hammers it, or staples it, or does whatever he has to do, and then that wood holds its position. But a robot doesn't know to do that unless you tell it that it needs to do that. So a robot thinks every piece of wood is perfect. And so we have to get away from thinking that we can fix and bring in perfect wood, and instead say the wood is never going to be perfect. It's never going to fit into a spec. We need robotic systems that can live in that environment. And so if you think about an automotive manufacturer, that would be like saying stamping's coming off the die for a door could be different every time. Well, your cars would look ridiculous. You would never be able to make a car. So automation companies like mine have trained ourselves that the first place we go is to the process engineering to fix the down the line process. And I'm not saying that that's not a part of things that need to be solved, but you're never going to have a successful integration project in this construction world or in Snowflake manufacturing. So now that I've got to the point where we realize that we've got to come up with a better way to do this, it's what we call our CAD to Fab. CAD to Fab takes the CAD drawings, whether that's in AutoCAD or Revit or whatever form it may be. It converts it, and so we build a digital twin of the machine. It converts it to XYZ coordinate data. It gives us material data, inertia, weights, things of that nature. And so that then is used to direct our robots to first build a fixture. It then directs our robots to then assemble the product into the fixture. And then it directs our robots to weld it, to fasten it, or whatever together. And so for those of you that are in manufacturing at the moment, what I've kind of described to you is something you're probably going to say sounds like a CNC and sounds like CAD-CAM. So taking XYZ coordinate data and passing that into a robot or a motion control servo, CNC, whatever it is, we've been doing that in Windsor cutting tools for a very long time. Where the complexity of CAD to Fab comes into play is that you're tooling, you're clamping, your fixtures, the material may be getting in the way of itself. So it's the physical environment of the material and the product that you're building that then becomes a part of the problem that you're trying to solve, which then takes it to a complete different challenge than any kind of like CAM generating software is. This is closer to auto code generating for programming a PLC assembly line than it is to CAD CAM. And so it breaks it up into the various sections, and these details are not as specific for this type of conversation as probably when I show you the videos and demonstrate it. But there's all kinds of challenges where there are limitations to the machine has to report back what those limitations are to inform the architects to redesign in different and better ways. So when you think about that challenge on the surface, the person that designs the F-150 wears a Ford shirt, sits in a Ford engineering office, was trained by the guy who designed the previous generation of F-150s and has a background in manufacturing engineering. And so he knows how to make the thing work in the automation of the machine. Architects don't. Architects care about space utilization. They care about leaving their signature. They care about how aesthetically pleasing it looks. The odd one will consult a structural engineer to make sure that the thing won't fall over. But for the most part, architects just care about how it looks. They don't care about how it's built. So what I'd like to do now is I'll show you some videos. I've got a number of videos to go through here. Maybe it's a point I would say, Lauren, that I would say if anyone does have some questions, I would open it up maybe for just a little quick question on what I've said so far. If nobody does, then I can go ahead and keep going through the some of the simulations and the videos and the real machines working. So I would open that up if anybody wants to sort of, if they have any questions on what they've seen right now or challenges, I'm open to all of that. If not, we can move forward.
Sure. Okay. Thanks, Brent. This is great so far. So if anyone has a question, please feel free to type it in the chat. So far, it doesn't look like we have any there, or you can go ahead and unmute yourself and ask your question.
Okay. No problem. I thought I would offer. Okay. So what I'm going to show now is it's a CAD to fab solution for a 3D volumetric client, but it's not for a home. This is for a utility power. I'll show the actual machine first. This is actually a machine that Steve and I are working on together. And so what you have here, to give you an idea of the range of things with CAD to fab, you've got a tapered utility pole, and that utility pole needs to have plasma cut holes. It needs bolts and brackets. It has these like things called vangs. All of this that needs to put on there. What they currently do is they have a guy with a tape measure who comes out, and they've got about 15 of these stations. He comes out, he measures it with chalk, he fits it, he puts it together, and then he moves on, and someone else comes and welds it after him. And so the challenge with this is because it's a utility pole, no two are the same. I mean, there are some that are the same, but they take a survey of the ground, and that survey informs where their brackets and where the things need to be put on there. So what this is showing right now is a machine that we've designed for a client that they're basically doing all of these functions that are currently being done by a workforce of welders that are impossible for them to find in their geographic location. So this is sort of the overview of the machine problem. What I'll show you now is the technical solution that we've written using the CAD to fab. And so Robot Studio was the previous thing that you were just looking at there. That's an ABB robotics simulation platform. This is an add-on that we've built in that Robot Studio to basically automatically generate the robotic path. And so here's an example of a nut and a bracket. The nut has to be put in place and welded. It has to be located where there's a hole. So there's a whole bunch of like traditional automation things that have to be accomplished. But the biggest thing for us is that this nut can be located physically anywhere on here. You've got clamping and tooling and your own robotic systems that you have to avoid. So all of these things have to be incorporated in this CAD to fab in order to be able to put that nut where that nut needs to go in this fixture and then weld it. And so this is kind of the example of the code generating portion of it. The engineer that wrote this, it maybe be better with him talking about what he's got right now is some shadowing. And so these are just talking about things in vectors rather than physically where that nut's going to be located, because we need to mount these to the two surfaces. So we've got a robot that comes in and puts a weld on here. And so that's what he's showing. And then I think if I scroll to the end, yeah. So then what he does is once he has that built in that profile, then he can come towards the end here and actually build the robot code automatically. Yeah, there it goes. So it builds the robot code automatically in here. So what we're really doing for these clients is we're future-proofing their business, where instead, the traditional way you would have to do this is every time your product changed, controls engineers would come in, they would redevelop new tools, they would reteach and reprogram the robots, and then you would run that product, and then they would do it again. That's similar to the retooling that goes on in an automotive assembly plant. And so this then is another variation of that we're working on the software for right now, and the application is called saddle welding. Saddle welding in oil and gas and in electrical, mechanical, and plumbing is a very challenging thing. So that's the saddle weld portion right there. So basically you cut an oblong shape out of a pipe, you put another pipe that protrudes out of it. And so to get a machine to actually weld that works very easily if you're doing 1,000 pipes that are all the same. But if you can imagine, when you look at a petrochemical plant or any type of building, the pipes are based on the design of that building. They're not the same. And so the reteaching that's involved and required to do that over and over and over again becomes not worth the effort of the expense of actually automating it. So what you end up doing is doing it all manually. So this is kind of an example of what the application looks like. Here is an example of the CAD to fab working in this regard. And so this one, I think, is probably the most this is the most expressive of what CAD to Fab is really capable of. So what Andrew was doing here is he just came for his first T. He has been able to extract the mechanical XYZ coordinate data from this. And so he has a whole bunch of nifty features. You know, when you think about the traditional side of welding, whether you're pushing, whether you're pulling, what your stick out is, all these type of things. So he can auto-generate all of that stuff based on the parameters. But what he's trying to show here is he just went and did that weld. Now he's going to go and resize the diameter of this pipe, the diameter of this pipe. He's going to put these pipes at a different angle, and the robot is able to decipher where the weld needs to go from the CAD data. And then it's basically giving that path back to the robot. So at this point, it's not dealing with all the clamping and all the other stuff that goes around and the tacking. All it's doing here is generating the path. But all of that other stuff is built into the kind of total solution for the CAD to Fab for this Snowflake. And so now, you know, put yourself in the shoes of a company who has not been able to use any automation because if this changes, then they have to reteach these robots. Now they have the ability, as long as they have the CAD drawings, they can have one welder standing there running 5 machines instead of what would have taken probably 2 guys per machine for fitting and welding. I think there's one here that he shows. Yeah, see here, he's got it on an angle now. So when I look at the simplicity of this little video, you know, it isn't as wowing as it is to me because I know what it takes to go in to make this happen. But this is like a very, well, let's put it this way. We've won an International Innovation Award from ABB back in 2020 for this technology. ABB, the robotics, the largest automation company in the world. Okay. And one other little sample down here is another version of this same machine. This machine is for a different client. It's a little more complicated. It has the fitting and the prepping in it as well. Oops.
I'm Cooper Lane, Vice President, Modular Construction with Brave Control Solutions.
And I'm Jason DeFazio, Director of Engineering.
We're a solutions provider located at the heart of North America's automation industry. And we're proud to be a valued.
There we go. Sorry about that. It's the problem running these things. Okay, so so what this guy is doing right now is prepping the parts. So the robot comes over. We've got our own proprietary fitting methodology that we use, and then the CAD to Fab technology comes in again. And so this is just an example of another type. This is in the construction industry, they call this a pipe spool or spool manufacturing. So that's what this is right here. It's for a mechanical, electrical, and plumbing client. That robot does that weld, and then it'll come in and put this on and do that weld as well, the CAD to Fab. So these are the CAD to Fab. If I don't pause that, it's going to keep on. So these are the CAD to Fab technology demos, but I'll show you it in practice now. So this guy, to kind of give you an understanding of what the 3D volumetrics is for modular construction. And this is a digital twin of our machine. And so what we put together quickly here were some of the variations that you may end up having to run in this machine. And so as you can see, all of the different configurations that are required. But what this means is, as an architect, as long as you stay within the physical parameters of this machine, use known material types, you can put spacing where you need to put spacing, where you need to put spacing, and you can continue to build that. So that's the different volumes. I'll show the actual machine right here working. Okay, so what you see right now in this machine is this is the part where the robots they've read the print and they're actually installing the tooling or they're relocating the tooling. So this would be because of joist spacing changes. Now the robots are actually doing their second phase, which is assembling the product in the fixture. And so I always caution people when I say, like, here's the 3D steel volumetric. But I think because we started looking at the utility poles and some other applications first, what you can see is that the underlying technology still behaves the same. It's kind of irrelevant of what the physical thing that you're building is. So now the fixture closes on itself, and then the robots, they go in and they do their welding. And so then as they do their welding, once they finish it, then they I didn't show it in there. Then we bring in the uprights and we'll do a 3D, the 3D volumetric side of it. So I can show this video, which I think is some details of the specifics of the welding, I think, which is really cool. So when I show this to a lot of people that are not in, our industry, they're amazed at the quality that you can produce, the quality of a weld. But of course, us being in Windsor, we know what robots are capable of doing from a weld standpoint. But what we try to explain to them is this. So as you look at this weld right here and this weld quality, this component could be located anywhere in that 3D volumetric space. And our robots, without being taught, can go and find this, put this particular weld has 3 undercuts, and then it has a weave on top of it. So it's got the capability of being able to actually find that, weld it, and make it weld quality. And that's what makes it so unique. That's what makes it different. The same thing is up here on the uprights up on top. Obviously sped up. I'm sure there's some people that wish the robots could weld that fast, but. And then I can show you one more video. Unfortunately, there's some other machines that we do have, but when I found out that this was being recorded, I'm not at liberty to share them, but they're wood clients along the lines of mass timber and some other structural wood panels, but they believe it gives them a competitive advantage, so they don't want to share them right now. But it's, again, the same kind of concept. So here what you're just seeing is some like flashy videos of the robots picking up the steel, moving it around. There's a lot of traditional automation components into this that goes into this cell. So one of the strengths of this region when we talk about Snowflake manufacturing is that all of the things that we build in for automotive, a lot of those principles apply, but it has certainly been a long journey from the construction domain knowledge, because the product that we're building is so much different. The Snowflake manufacturing component of it is so much different. Okay. So this is from a construction standpoint, but again, my background has been in automotive. And so I, probably a year ago, I ordered one of those Rivian electric pickup truck. Now it was probably 3 years ago, and still haven't got it, but that's a whole other story. But what Rivian did is they made that pickup truck, and then they started saying, they want to make different options, and then they partnered with Ford, to do the electrical underpinning. And so what it made me think of was in the 1970s and the 1980s, a body and a carriage became a coach. So to a layman like me, I would just say, like, that's a coach, right? I know what a coach is. I've seen an old Western movie and whatnot, but really it's comprised of a body and a carriage. And so the body, that was the craftsman. And the craftsman made the wheels and the spokes and the structure, and they put all it together. And then you had the artisan, and the artisan, would decorate these things out, and he or she would make them custom to whomever they wanted, or however they wanted to do it. And so when you start to think about that methodology, you ask yourself, well, what does this mean for customization? Like, what is the future of this? And so this is the Rivian skateboard. And the Rivian skateboard is a battery pack, a computer, a powertrain. But if you were Apple and you said, well, I want to make a Apple car, maybe it's a high value, it's a low volume, high value production thing that you're going to do. And of course, this is maybe a little bit out because you've got safety concerns and things like that. But I mean, at some point, we're going to get to a point where cars are self-driving and there's no danger, and so you can just have these like brand name carriages that go on top of a skateboard. And the challenge that we're going to face is when that starts to happen, how are we going to be able to manufacture that in any meaningful way in an automotive manufacturing facility? And so I think back to, I think in 2019 is the last year they made the Dodge Viper. And that year, and a few years previous, they had some ridiculous number of paint colors. And so they were able to, you could customize the paint in a whole bunch of different ways. Well, in order to customize that paint in a whole bunch of different ways, you had to have that sort of Snowflake manufacturing mindset in that machine. And albeit paint is very simple because the path is the same, you're just switching a valve to change the color and things of that nature. But that was a market-driven customization that you want to put into manufacturing. And so that was a very, very, very basic version of what I see in the future is, you know, you're going to build this Rivian, but this Rivian is also going to be able to be these different brands that someone's going to be able to build their own carriage. But what happens if it takes off? They're going to have some type of a way that they can actually manufacture. And so for the future, this highly customizable thing, I mean, think about clothing and the market business that you could do if your factory could customize clothing that people could choose themselves and design themselves and spit out. I mean, it would be an industry unto itself. So the future, what does the future mean for manufacturing? Traditional manufacturing. So I bring this up to show you the 6 previous generations of Mustangs. Well, every time Ford builds a new Mustang, it costs them hundreds of millions of dollars in tooling changes. Every time their manufacturing facility needs a major overhaul, it could cost upwards of $1 billion. And so think back to where Elon Musk is still making his Model S. He hasn't had to go through those hundreds of millions of dollars worth of tool changes. And I don't know how much longer he can hold on to it, but it gives him a profitability advantage over Ford that Ford has to bake in the cost of that tooling. Well, if Ford designed their next generation assembly plant with a Snowflake manufacturing mindset, would that mean that all they would have to do is replace the tooling and it would be a much reduced cost, or even if that tooling was adaptable to be able to grab onto a different shaped part, a much reduced cost in order for them to be able to produce a new vehicle? And so do we get to a point where they start to have some of this customization or, you know, things of that nature that they can do in manufacturing? And I don't see, I know GM for one, I can't remember when this came across my desk, but they are trying to look for new advanced manufacturing and flexible manufacturing ways. And so the traditional automotive flexible manufacturing model is this: if you can run 5 products in your plant, it gives you business flexibility. That means if the minivan starts to suffer in sales, but the Dodge Charger goes up in sales and you can make them on the same line, you have the ability to pull a switch, pull a lever, and change your volumes. And that today is what we call flexible manufacturing in automotive. But again, I say it's only on a business level. When you talk about truly flexible manufacturing, it means that you can account for variations in your factory that you didn't know about ahead of time. So I think that this is something that you start to see, the Ford Motor Company going towards. So I'm a Star Trek nerd, and this is a little Star Trek video of what I really think the future of this looks like.
Like me a thick Kansas City steak and some country fried potatoes and a mess of greens. Oh, hell, just forget all that and give me a martini straight up with 2 olives for the vitamins.
And so it's the Star Trek replicator. And I sat on a panel a number of years ago with the provincial government, or maybe it was the federal government, and they started to tell me about what their advanced manufacturing looks like. And they were speaking of this cottage industry. And so at the time, you know, I'm used to these large automotive assembly plants, and it's sort of like a centralized model where all the natural resources, all the products, like, you know, when you think about a new campus being set up for a new automotive assembly plant, all the feeder plants are now built so they don't have to transport all the stuff. And that's kind of been our manufacturing model for a long time. And so what this sort of think tank, and I was just there observing and with some other automation companies in town, and I think they were just trying to like get an opinion from us on what we thought of this. But what they were saying about this cottage industry is they said, you know, with 3D printing and advanced manufacturing, they are seeing that potentially we could go to smaller manufacturing facility footprints, more evenly distributed, instead of the big guys like, you know, Ford owning these massive things. It could be a lot smaller companies. And so I thought about that at the time, and I couldn't draw like a conclusion to like how we go from here to there. How would you be able to have all the natural resources? You know, if you're building a car, just say you need windows, you need all these things, you know, to build a small lot of vehicles. But when I start to look at this Snowflake manufacturing, the vision that I then have in this case is, well, what if you take the Snowflake manufacturing in its infancy and its day one right now. So if you look at our 3D volumetric machine, or you look at some of the other examples I gave you, it's really like we've built a 3D replicator. It's just a very, very crude one, right? It takes the raw materials of the steel tubes and it changes them into a square box, structural steel thing. But as materials improve, as 3D printing improves, as these other things, as we start to be able to control our processes more, do we actually get to a part where we could have a factory with a Snowflake mindset, where the robots can create and direct themselves, the fixtures can build themselves, the raw material comes in, and we can actually start to produce manufacturing from raw material within that place and give you that whole level of flexibility. So, if you want to ask me on a timeline on that, that's impossible. I don't know. I have no idea, but I do feel like this is the direction, because it's customer demand driven. This is the direction manufacturing is going to go. At my company at Brave, we're definitely, I would say, on the leading edge of that. I'd rather say it's probably the bleeding edge, just because of, the challenges and things that we face as we're trying to evolve and innovate and design and build these new technologies. But this is, to me, I feel like where this industry is going to go. And I think that the opportunity that presented itself in construction, because the construction problem is much greater from an automated standpoint than manufacturing in traditional automotive, it pointed to that Snowflake manufacturing problem. But now that I have this new mindset, I look back at automotive and I see so many areas of improvement in automotive or any type of sort of consumer good manufacturing. So that takes me to the conclusion. Hard to do these online without being able to look at the audience in the eye and see any type of facial expressions or feedback. So hopefully I didn't lose you guys, and it was interesting. And again, I guess I would say I would open it up now to any questions of anybody that has anything for me, and we'll go from there.
That was fantastic. Thank you so much, Brent. And I like the music that you choose as the background on your videos. That was good. It was a nice little break in there. So anyone who has questions for Brent, please feel free to unmute yourself, ask them out loud. You can also put them in the chat. I see Stephen's got it. Go ahead, Steve.
Hey, great presentation, Brent, and thanks for including us in on that. Can you talk a little bit about how the customers have to change their landscape and their mindset with their staffing requirements, and how they have to evolve to adopt this type of machinery in their current practices?
Yeah. So Steve, that's a loaded question, because it's part of the thing that we've gone through. But the biggest thing that I would say in construction is, I've got a slide and I show a picture of a coffee maker. And so the construction mindset is, you want a tool to do a job, you go buy a nail gun or you buy a forklift, and the forklift has a button, you push, it goes up, has a button, you push, it goes down. And so the reason I use the coffee maker analogy is that in a coffee maker, you push a button and that button puts out a coffee. And in automation, when you look at a Ford assembly plant, Ford, next to their laborers, the next most populous employee discipline is engineering. So Ford engineers a product, they engineer the line to make that product, then they engineer the running of that product. So it's like engineering. In construction wants a hammer. They want a single thing. And so the big mindset shift for them is that they've got to increase their IQ from a technology standpoint, from a maintenance standpoint. They've got to become a manufacturer. And so what we see a lot in construction is they're manufacturing under a roof, like when we call it offsite construction. It's a climate controlled roof, but they're doing all the same things that they do on site. They're just doing it and it's air conditioned, and that's the only difference. And so that manufacturing organizational structure, that manufacturing mindset is one of the key things that they need help with, and they don't even know that they don't know it. And so they need us to help sort of explain the pitfalls that we've gone through with clients so that we can get them started on the right foot, number one. Number two is this old analogy of if you give a handgun to a monkey, can you really be upset that the monkey's shot everybody? And so, this is it comes out sounding negative. And I guess there's no other way to say it. It is negative, but it's like, we need to ramp up the technology ability and their technology IQ and the sophistication of their automation. And so what we want to be able to do with all of our clients is say, like, here's a roadmap, giving you a stage 4 fully automatic lights out manufacturing process when you're still using hammer and nails to pound studded wood walls is a recipe for failure. And so what we need to do is we need to understand what your capabilities are, and then we can help you fit a solution that works for your needs, but on the same way help you increase your skill set so that the next solution can be more sophisticated. Okay, I see a question in here.
That was a very in-depth response, Brent. That was lovely. So I'm going to read out this next question for you. So this is from Matthew.
Yeah.
Regarding CAD to fab as an approach to Snowflake manufacturing, I am curious about how the process incorporates needs such as different welding types. Of course, this can be expanded to all ends of the manufacturing process, but I'm curious as to what current capabilities allow for.
Yes. So the first thing that I usually try to, when I show only welding pictures and I show only welding manufacturing, then the question lends itself to be, welding specific. And so what I try to level set, what I say is, pretend the robot's holding a black magic marker. So from a robot standpoint, I need to get that robot to an XYZ position in space. That material that's at that position has to have the correct parameters. So in welding, it has to have the correct gap. We have to know if there's deflection, if there's bow or whatever there may be, and the robot then has to be able to follow with that black magic marker exactly where it needs to do, just like a human would do. And so when it comes to different welding types, basically the short answer to that would be, if you have the mechanics on the machine to be able to do a particular welding type. So if you have the sophistication in the weld controller, if you have the right type of wire, the right type of gas, then you can work within those parameters to get to that XYZ position. There's all different types of ways that you can validate welds, through existing current means and through the controllers themselves. But what I really want to try to stress is that, we're designing and building applications right now that use glue, that use nailing, that use CNC routering, putting chainsaws on the end of robots. And so all of these things are sort of the same difference between different types of welding. They've got a set of parameters, a set of rules that have to be adhered to. And then the main part is getting that robot to the XYZ position without with the issues with clamping and all the other things that are in the way, in a flexible fixture type of configuration so that it can perform the job that it has to do. And so the other side I'll say is, we're working with a client at this exact moment. They don't want robots. They just have bad taste in their mouth. And so to us, a robot is, as we expect, a 6-axis, manipulating arm, but it's also a 3-axis or 4-axis gantry. There's a lot of different things that could be sort of classed as a robot, but at the end of the day, for us, it always comes back to, can we quantify, in a weld, for example, if you need a weave, if you need your different feed rates or whatever it is, that's a variable type for us. And so that operator, if you go back to the very first slide I showed you where my engineer was programming or setting that up, he's specifying at that moment what current, what weld, what wire feed. He's specifying that information to then direct that robot to be able to use the tool that's on the end of it to perform its task. And so if that's painting, if it's gluing, it's different feed rates for the glue, it's purge times, it's things like that. So I hope that hopefully that answers the question.
We've got another question. Please go ahead, Antonia.
Thank you for pronouncing my name properly, Lauren. And thank you, Brent, for having us all. I would like to hear your thoughts, Brent, on the possible backlog of robotic units needed to produce the number of production lines that are going to be needed.
Yeah. So you're hitting the nail on the head of I was on a phone call 2 hours before this with a client of ours in California, and he had a client, a competitor of mine, pitching him a large robotic cell out of Japan. And the guy said, he showed me this massive line. He goes, yeah, the guy told me you can have it in 6 months. And I was like, all right, I'll tell you what. have that guy tell you that if he delivers it one day after 6 months, you won't pay him a dime for it and you get the machine.
Oh,
Because
that's good.
what's happening in this industry is we've got this tremendous backlog. The supply chains have been, severely damaged. And so it's not even about, I believe that if the demand increases, companies like ABB can keep up with it. The challenge that we're having right now is I've got a client that comes to me and says, I'd like to automate my factory. It's going to take me 6 months to convince him not to be afraid of automation. It's going to take us another 3 or 4 months as we're going through this to complete kind of what the designs that look like. And then I'll say, okay. And then from that point, it's 2 years until we can get a line on his floor. Well, he's worried about his demand ramping up in that first 8-month period, and he needs the automation by that time. But then he doesn't have the confidence or the courage to kick off the engineering for that automation. So there's the thing I guess I'm trying to say, I'm talking around in circles here. Let me summarize it in another way. In automotive companies are experienced with buying automation. They understand automation. Their engineers specify it. They write functional specs. They know what they're doing. When an automotive company comes to you and says, I would like to buy a robotic cell that has this features in it, you quote it. If you're the least expensive of the 3 bidders he has, you win that job, you go forward and they go. In construction, they don't even know if they want it yet. They don't know if it'll help them. They don't know how much money it'll save them. And so we're trying to help answer all these questions. I'm dealing with the CEO level at construction companies, and I can honestly say I've never met Bill Ford Jr. at Ford. He's never came to me and said, hey, Brent, I really want to get into the details of this robotic cell you're giving us, right? And I joke at that, but I think we've got even larger problems than the delivery supply chain issues of robots, which is a huge problem. I think that's a problem that will eventually rectify itself. We'll get back to sort of pre-COVID delivery levels. But I think that there's other bigger challenges right now than even the delivery stuff. I mean, that's impacting everybody, but it's going to get, the delivery levels will get themselves sort of back out, and water kind of finds its level. And then I think if all of a sudden we needed 1 million more robots next year, that's what free enterprise does, right? ABB will set up 5 more factories and build 1 million more robots.
Can I ask before we go, who's the fastest gun in town so far?
The fastest gun in town? What do you mean by that?
Robotic producer.
Oh, we use ABB, and we've got a great relationship with ABB. We integrate all of them, but I haven't had to buy another robot yet during this time. And so what we're finding are people are giving you like 5-day, here's your quote, delivery expires in 5 days. And so you're like, what do I do with this? And it's not until you actually get an order that you can then really sort out when that delivery is. So yeah, we've been using ABB. They're not great. They've definitely doubled. But I don't know. The guy that these guys were talking about were Fanuc robots. And I'm just like, I don't know where, unless you've already bought them, I don't know where someone comes up with 15 Fanuc robots in 6 months time when it's going to take you 3 weeks to 4 weeks to ship the damn machine over here. Like it's crazy, but I don't know.
I understand they have an Alberta operation. Fanuc does.
Oh, do they in Alberta? Yeah.
All right. Thank you so very much. I have to attend another meeting, but thank you all. Take good care. Talk to you soon.
Thank you. All right. So we've got 2 questions in the chat. Those are going to be our final 2 for this evening. They're somewhat related to each other. So our first question is from Alan. Alan would like to know if there's a particular software tools or techniques that enable your manufacturing to be more readily adaptable to changing specs.
So by changing specs, do we mean like to manufacture different product types, or can maybe Alan clarify what he means by changing specs?
So as we give Alan a second to chime in with that, I'll move on to the second question, which is related to Alan's. What software platform is CAD to Fab based on?
Okay, so CAD to Fab we've built it on Grasshopper and Rhino, but it's basically just it's a 3D solid environment. So when we can translate a step file, we can bring in the solid CAD data from any international or from any universal exchange that is using SolidWorks or AutoCAD or Revit or whatever the model might be to pull the XYZ stuff out of it. So it's just basically similar to like 3D design software. And then on the same sense, when we build our digital twins, there's a bunch of different platforms. So one of them being Robot Studio, another one is Unity, another one is Siemens PLM software. So we can build and animate these. We can build and animate the digital twins in an array or a variety of different ways.
Excellent.
Oh, customer. Okay, I got this. Okay, customer changes. So I'd like to know if the figure software tools that use me. Okay, yeah. So what I would say is. There isn't, and that's what the problem is with the industry. And so the biggest challenges faced is that architects don't even know. Here would be the best analogy I could use. I mean, we're from Windsor. So if you were going to design a big steel structure and you wanted it to be machined, one of the rules that you would say is, okay, how many times do you have to unclamp it and rotate it and move it and reclamp it? So the more times that you can eliminate having to do that, the more that you can design that product from being able to be assembled and built from its one sitting location, the easier that will become. Architects don't think that way. So an architect just wants to build or design something to be built. And so, making like say a structurally insulated panel, what we're finding when we first engage with the client is that panel might need to be flipped 3 or 4 times in the manufacturing process. There might be super intricate cuts that need to be made that they're not even informed as to what the impact of that is. So the very, very, very first thing that we can do, and actually we're just kicking off an engagement with it at this exact moment, is go down to their manufacturing process, look at their product, and be the automation and manufacturing side of what they're trying to accomplish. And so when we start to get them thinking in terms of what causes them problems and then what doesn't cause them problems, then they're starting to understand how the specs and the changes will impact things. Now, once we've moved to the next phase with them, where we start to build them a machine or a digital twin, what we give them, and I can switch back to show you the slide part here. So once we've built them a digital twin, this little report right here is the information that helps them design better. So they will first make their mechanical design like this. We can take that mechanical design and run it in the virtual environment. So before it's ever hit the floor, and then you see the different colors in here. That's because of the, That's because of the go, no go that gets reported back to them by the virtual testing in here. So the best way to take we've found anyway, so I call it a break fix approach. It's certainly not the best way. It's not the best way to work in general, but it's the best present tool that we have, which is they design it, we put it in our digital twin, it breaks before they've sent it down to the floor, and then they come back and say, well, I didn't need to actually design it that way. Maybe I can make this improvement. And then they get instead of being 30% built in the fixture now, maybe it can be 90% built in the fixture. The long-term fix is there's a thing in construction called BIM. BIM is building information management. And so we have to limit their design choices in a BIM software. So there's softwares like BIM 360, and there's a bunch of different ones out there. But basically that would be like the toolbox of things that they get to use when they're trying to design or build things. So once we've been at this long enough, we'll have enough information to inform the BIM software what can and can't go. But as it stands today, break fix and first version is sit down with them and just talk to them and open their eyes to a whole new world. This presentation, 30% of it or 40% of it is the starting presentation I give to architects to help them work through these things. So.
I love how your answers are. That's fantastic. Thank you so much, Brent.
Mm-hmm. No problem.
This was a great presentation. Really happy that you were able to join us. So thank you for being here. And thank you, Nicole, for setting all of this up, advertising through Automate Canada and all of that. Nicole, Brent, any final words before we close things out for the evening?
I'd just like to say thanks, Brent. That was great. And thank you everyone for attending. I look forward to more events in the future.
Awesome. Yeah, it was my pleasure. Yeah, thank you guys. I've I love talking about this subject. I'm very passionate about it, and so the more ears that hear it, the more believers we have in what we're trying to accomplish here. Because I think, when you circle back to, you can tell. I mean, I love building technology, but I always say, we used to build technology for Ford, and it gets tired. It gets hard to get out of bed in the morning to make a Ford shareholder 0.0001% more profit. The tools, the machines, the things that we're building now are actually having real impact in our own communities when it comes to affordable housing and hospitals and things of that nature. So, it's I love the technology side, but it really feels like we've got a meaningful purpose now on why we're trying to do this. So it's good. So I appreciate everybody's time.
Amazing. Thank you so much, Brent. Hopefully we can have you back for a follow-up in the future. This was very informative. So thank you for that.
Excellent. Okay. Thanks, guys. And
Thanks,
I see
everyone.
people, saying you want to connect later. Just, definitely connect with me on LinkedIn, and we can set up some conversations after.
Beautiful. Thanks, everyone. Have yourselves a great evening.
Thanks, everyone. Thanks, Lauren.
Thank you. Bye.